What do you know about quantum mechanics?
I have a grasp on the basics, then you're doing it wrong. Is light made up of particles or waves? Quantum mechanics says it's both. How could it be both? To answer this question, let's take a dive into the science behind light.
Light is created when an electron in an excited state drops down to a lower energy state and loses energy. This energy is released as photons, which we perceive to be light. In the 19th century, scientists observed that light makes interference patterns, the type of patterns that you see when you drop two objects next to each other in a pond.
Since only waves make interference patterns, scientists assumed that light was made up of waves. However, in the 20th century, scientists did experiments that are pretty sure light acting like a particle.
For instance, if you shine light into a metal, the light transfers its energy into the atoms in the metal.
So scientists came up with the wave-particle duality to explain this. The wave-particle duality states that photons are both a wave and a particle, but they can never be observed as both at any given time.
To better help you understand, take this soda can. If I cast a shadow of the can and have my friend observe it, he either sees a circle or a rectangle, depending on how I orient the can. If I then asked him what shape the object is, he would say that it was sometimes a circle and sometimes a rectangle.
But in reality, it is much more than a circle and a rectangle put together. The problem is that my friend was looking at shadows of the object and not the object itself. As is the case with light. It sometimes acts like a particle and other times acts like a wave. But in reality, it's something much more complex. But what if I told you that the wave-particle duality applies to all particles and not just photons? This groundbreaking discovery led to the birth of quantum mechanics. Even with our limited understanding of quantum mechanics, we've been able to achieve an unimaginable level of innovation. Everything from laptops to MRI machines uses chips that rely on our understanding of quantum mechanics. Figuring out what exactly all these particles look like and why they behave the way they do could help us expand our knowledge on the cosmos, while also allowing us to innovate better. Quantum mechanics isn't just a step forward, it's a huge leap forward.